Good morning everyone. I am Arya Sajeev and today I'll be explaining about the medium access control, commonly called the MAC, and also we will learn mostly about the concept of ALOHA. So MAC is a sublayer of the data link layer in the computer networks. Its main purpose is to control how multiple devices share a communication channel. In many networks like wireless LANs or Ethernet, many devices try to send data through the same medium. If two devices send data at the same time, their frames collide and the transmitted data becomes corrupted. Therefore, we need rules that decide who can transmit, when they can transmit, and what happens if a collision occurs. These rules are called the medium access control protocols. So as we can see, the data link layer is divided into two functional sublayers. The first one is a logical link control, which manages error control and flow control. The second one is medium access control. This manages how multiple devices share the same transmission medium. So MAC, it specifically deals with the access to the physical channel. Without the MAC protocols, the devices would continuously interfere with each other's transmissions, resulting in frequent collisions and poor network performance. When multiple nodes share the same communication channel, they may try to transmit data simultaneously. If this happens, their signals overlap and cause a collision. So what happens during a collision? The transmitted frames are corrupted, the bandwidth of the link is wasted, the frames must be retransmitted. So to solve this major problem and this issue which we face, we use the multiple access protocols. The goal of these protocols is to minimize collisions and efficiently use the available bandwidth. A good MAC protocol must decide when a station can transmit, what to do if the medium is busy, and what to do after a collision, and how to detect whether the transmission was successful. So one category of the MAC protocols is called random access protocols. In the random access systems, no station has priority over another station and there is no fixed schedule, and every station competes equally to access the channel. Whenever a station has data to send, it checks the state of the medium and decides whether to transmit or not. Because the stations compete for access, collisions may occur. But the protocol includes methods to handle these collisions which occur. One of the earliest and the simplest random access protocol is ALOHA. And in ALOHA, we will further study what is pure ALOHA and what is slotted ALOHA and which has a better efficiency. So now let us discuss about pure ALOHA. Pure ALOHA was developed at the University of Hawaii in 1970s for wireless communication networks. It is one of the earliest methods used to allow multiple stations to share a communication medium. The working principle is very simple. First, all frames transmitted by stations have equal length. Second, if a station has data to send, it transmits immediately without checking the channel. After transmitting the frame, the station waits for an acknowledgement. If the acknowledgement is received, the transmission was successful. But what about if the acknowledgement was not received? If no acknowledgement is received within the expected time, the station assumes that a collision occurred and retransmits the frame after waiting for a random amount of time. Because the stations transmit at random times, collisions are very common in the pure ALOHA. Okay, so now let us look at this figure. Here in this figure, it shows multiple stations transmitting frames on the same shared medium. And because the medium is shared, if two frames overlap even by 1 bit, then for sure definitely a collision occurs. And when a collision occurs, both the frames become corrupted, and hence both of these frames must be retransmitted also. So this is why collisions are a very major issue in pure ALOHA networks. Now the collisions is somewhat handled with the concept of the slotted ALOHA also, which we will be learning further. So now we discuss about the vulnerable time in pure ALOHA. In pure ALOHA, we define something called the vulnerable time. Vulnerable time is the period during which another transmission can cause a collision. As we had seen in the before diagram, even from various channels, multiple messages are sent, and if it is sent at the similar time in the transmission, then a collision is occurring. So if the time required to transmit a frame is t seconds, the transmission time of that frame it's t seconds, then the vulnerable time in the pure ALOHA is given by 2 into the time, 2t seconds. This means that a collision can occur if another station starts transmitting 2 points. First one is during the t seconds before the frame transmission starts, and second one during the t seconds after it begins. So you are not supposed to send t seconds after it begins and t seconds before the frame transmission starts. So the total vulnerable time, it becomes 2t. Now let us discuss about the efficiency of the pure ALOHA. To measure the efficiency, to measure the performance of the ALOHA, we calculate the throughput or efficiency. Throughput means the percentage of the transmitted frames that arrive successfully without occurring any collision. So for pure ALOHA, the throughput formula is S is equal to G into e raised to minus 2G, where G is the average number of frames generated and S is the throughput. The maximum throughput occurs when this G it is equal to 0.5. At that point, the maximum efficiency it is about 18%. This means that only 18% of the transmitted frames are successfully received. Okay, so now let us solve this example. A pure ALOHA network transmits 200-bit frames on a shared channel of 200 kbps. What is the requirement to make this frame collision-free? So as we can see, for solving this, first we calculate the frame's transmission time. So the transmission time is equal to the frame size divided by the total bandwidth. So over here it will be the 200 bits divided by 200 kbps, and after solving we get it as 1 millisecond. So as we know, for pure ALOHA, what was the vulnerable time? The vulnerable time is 2t. So over here the vulnerable time becomes 2 into 1, so it will be 2 milliseconds. This means that if another station transmits within this 2 millisecond period, then for sure a collision will occur. But otherwise, in any other time other than this, if it is sent, then there won't be any collision occurring. Okay, so now let us look at one more example. A pure ALOHA network transmits 200-bit frames on a shared channel of 200 kbps. What is the throughput if the system, the all stations together, produces 1000 frames per second? So over here the system is generating 1000 frames per second. So the frame transmission time, again it will be 1 millisecond. That means, what is the meaning of this? It means that the system generates 1 frame per millisecond. So the value of G it will be equal to 1. Now using the throughput formula which we have, that S is equal to G into e raised to minus 2G. On substituting G equal to 1, we get that S is equal to 1 into e raised to minus 2. And after you solve, you will get the answer to be 0.135, which means approximately around 13.5%. So what is the meaning of this? It means that if 100 frames are transmitted, only about 13.5% of this, which means only 135 frames will be successfully received when we are using the pure ALOHA. Using the same example, I will also be explaining how it would be for the slotted ALOHA. But before that, let's discuss about slotted ALOHA. So what is the slotted ALOHA? To improve pure ALOHA, the slotted ALOHA protocol was developed. In slotted ALOHA, time is divided into equal slots and each slot is equal to the time required to transmit one frame. stations are only allowed to transmit at the beginning of a slot. So as we can see over here, in the next this one in the diagram, we will be seeing there are different slots present. Like in the pure Aloha, we could send whenever we wanted, but in the slotted Aloha, there are slots, there are time slots which has been given, and only in the beginning of the slot you are allowed to transmit. And if a station misses the start of a slot, it must wait until the next slot. And because the transmissions are synchronized with the time slots, the probability of the collisions is reduced. The throughput formula for the slotted Aloha is S is equal to G into e raised to minus G. The maximum throughput occurs when G is equal to 1. At this point, the maximum efficiency is about 36.8%. Over there we had seen it was around 18%, so which is often rounded to around 37%. This means the slotted Aloha, it's almost twice as efficient as the pure Aloha. Clearly we can see. Okay, so now let us look at an example for slotted Aloha. This is the same question which we had solved above, but now we will be solving it using slotted Aloha. So we are given that in a slotted Aloha network, it transmits 200 bit frames using a shared channel with a 200 kbps bandwidth. Find the throughput if the system, all stations together, produces 1000 frames per second. So as we can see here, again the frame transmission time on the calculation we get is 1 millisecond. So again the G will be equal to 1, and using the slotted Aloha formula, S is equal to G into e raised to minus G, and we substitute G equal to 1. So we get S is equal to 1 into e raised to minus 1. This is equal to about 0.368 or around 36.8%. So over here, out of 1000 frames, about 368 frames will be successfully received. You can clearly see the difference of the value we had got when we solved it using for pure Aloha versus now when we did it using for the slotted Aloha. Okay, so to conclude, in networks where multiple devices share the same communication medium, there must be a way to control how the devices access the channel. This responsibility is handled by the MAC sublayer, which is a part of the data link layer. And the main goal of the MAC protocols is to coordinate transmissions, reduce collisions, and utilize the available bandwidth efficiently. And without these protocols, the devices which are transmitting simultaneously would cause collision, resulting in corrupted data and wasted network resources. And one category of the MAC protocols is the random access protocol, where all stations have equal priority and compete to access the medium. Among the earliest and simplest of these protocols are the pure Aloha and the slotted Aloha. In pure Aloha, the stations can transmit data at any time whenever they have frames to send, and after transmitting they wait for an acknowledgement. If the acknowledgement is not received, then the frame is retransmitted after a random delay. However, because the transmissions can occur at any moment, collisions are very frequent, and the vulnerable time in pure Aloha is twice the frame transmission time, or 2T, which means that the collisions are more likely. As a result, the maximum channel utilization of pure Aloha is relatively low, which is about only 18%. To improve this, we have the slotted Aloha, and in this method, the time is divided into equal slots that match the frame transmission time, and the stations are only allowed to transmit at the beginning of a time slot. The synchronization reduces the vulnerable time period from 2T to only T, which significantly reduces the probability of collisions. Because of this improvement, the slotted Aloha achieves a higher maximum efficiency of approximately 37%, which is almost double the efficiency of the pure Aloha. Therefore, the key difference between this pure Aloha and the slotted Aloha, it is that the resulting in of the fewer collisions and better channel utilization. As you can see, pure Aloha allows transmission at any time, while the slotted ALOHA, it restricts the transmission to only fixed time slots. So in short, these protocols demonstrate how controlling access to a shared medium can significantly improve the network performance, and they serve as the foundation for many modern medium access techniques used in today's communication. So now we are going to summarize all the topics. So let's start with the pure ALOHA. Pure ALOHA is one of the simplest random access protocols. In this method, any device can transmit data whenever it wants without checking whether the channel is free or not. Because of this, collisions are very common. If a collision happens, the device waits for a random amount of time and retransmits the data. This makes the pure ALOHA simple but not very efficient. To improve this, slotted ALOHA was introduced. In slotted ALOHA, time is divided into equal slots and a device is allowed to transmit only at the beginning of a time slot. This reduces the chances of collision significantly compared to the pure ALOHA. However, it requires synchronization between all the devices in the network. So both of these, they come under the random access protocols. Random access means that multiple devices share the same communication channel and transmit data randomly instead of following a fixed schedule. The main goal is to use the channel efficiently while managing these collisions which occur. Now let us talk about the channel utilization. It refers to how effectively the communication channel is used for successful data transmission. In simple terms, it is the fraction of time during which useful data is being transmitted without collisions. Higher utilization means better performance of the network. When we look at the efficiency of the pure ALOHA, it has a maximum efficiency of about 18.4%, which is quite low due to the frequent collisions which occur. However, the slotted ALOHA, this improves and it reaches a maximum efficiency of about 36.8%, almost double that of the pure ALOHA. To achieve even better performance, we use the CSMA, which stands for Carrier Sense Multiple Access. In CSMA, a device first checks whether the channel is busy before transmitting. So this reduces the number of collisions significantly. So as a result, CSMA can achieve efficiency levels of around 80 to 90% under good conditions, making it much more effective than the ALOHA based protocols. So in short, pure ALOHA is simple but inefficient. Slotted ALOHA, it improves the performance using time slots, and CSMA provides the best efficiency by sensing the channel before transmission. Channel utilization helps us measure how effectively the network is being used, and the random access protocols allow multiple devices to share the same communication medium. Thank you and hope you all understood these topics.